Hi folks, this is going to be chapter 16 on solutions. I'm going to just call this part 2 of your notes. The notes that so far this chapter we've taken in class, and we're just going to take this section out as homework out of class. So a lot of this stuff you've already kind of covered in class through activities, so this is just background knowledge so that you have it in your notebooks and you can refer back to it. So we're talking about solubility. And a really simple definition is the ability of a substance to be dissolved. Now, that depends on the solvent that's being used. Most of the time it's water, and that also depends on the temperature and a few other factors. So, three major factors we're going to talk about that affect dissolving or dissolution. First one, increasing the surface area of the solute speeds up the rate of the dissolving. All right, so my example, a sugar cube versus granular sugar. So if we have a sugar cube and then if we break it apart into smaller pieces, we increase the surface area. And the more surface area means the more contact that the solvent can have with the solute. So if there's more contact between the solvent and the solute, there's more dissolving happening that can pull it into solution quicker. Another way is to agitate or stir. Again, more contact, more dispersal of the solute in the solvent speeds up the rate of solubility or dissolving. And the last one is heat. If we heat the solvent, we speed up the dissolving process. We're increasing movement of the solvent and causing more collisions with the solute, which again causes a quicker rate of dissolution. Right? And with online notes, guys, feel free to pause then because I'm not going to slow down. Let's talk about solution equilibrium. Now we did a POGO packet on this idea of saturated and unsaturated, so we're just going to get some of this background knowledge in our notes. Equilibrium, again, it means we have a balance. So the physical state in which the opposing processes of dissolution, so dissolving, and crystallization of a solute occur at equal rates. So that's when we have a balance and equilibrium. So what I mean, if this were a solid down at the bottom here, and then this is the dissolved state, we have an equilibrium. The same amount of particles are going to a solid state as they are dissolving in solution. So to us, it would look like nothing's happening. Then we get to these terms. So you define these in class already. Saturated solution is a solution that contains the maximum amount of dissolved solute. Unsaturated could still hold more solute. And a new term that we didn't cover in our POGO packet is supersaturated. So this is a little bit different from saturated. This is a solution that contains more solute than it should be able to under normal conditions. So we're going to be, you should have made one of these in class today, but it's very unstable. All right, so what you do is you heat up a solvent to force it to dissolve more solute, and then you slowly cool it down so that all of a sudden you get this unstable solution that's holding more solid than it should be able to, and that's why we get those cool crystallization reactions. So again, unsaturated could dissolve more, saturated cannot dissolve anymore at that given temperature, and supersaturated becomes unstable and crystals form when you add more solute. And we'll take a look at some of the solubility curves. These just give us an idea of the solubility of different solutes at given temperatures. So you can see here we have solubility would be our dependent variable, and temperature is our independent variable, the one that we are controlling. And we have various ionic compounds, so these would be salts that are dissolved in solution. If you notice, one of these, the solubility decreases as you add temperature. The rest of them increases. So the reason for that is this is actually a gas. So gases solubility decreases as you add heat, and that makes sense if you think about it like a hot like a Coca-Cola. If you leave it out on room temperature and it warms up, you lose that gas that's dissolved in it. But the rest then would be solids dissolved in a solvent, and in this case it's water. So here's the first question: what is the solubility of KCl at 40 degrees Celsius? So would look for 40 degrees Celsius, find where we cross the line, and it looks like our solubility is a little bit under 40, so maybe 39, probably not even 39, closer to 40, okay? And here's a question. Are the following solutions saturated, unsaturated, or supersaturated? So let me get my pointer and I'll show you how to find this out. So you need to know the terms, what that means, saturated, unsaturated, or supersaturated. So at 40 degrees and at 40 grams, so that'd be here, and 60 degrees Celsius, find where that point would be, which would be right here. Okay. It would be right here at this X here. And you find NaCl. If you notice, our point is above the line. So it would mean that if we have a solution of 40 grams of NaCl and 60 degrees Celsius, we have a supersaturated solution, right? Because we have more solute than it should be able to hold at that temperature. Take a look, 60 grams of lead nitrate at 24 degrees Celsius. So 60 grams, 24, looks like it's right about on the line here. So if it's right on the line, then it's saturated. We're holding the max amount we could at that temperature. And then 10 grams at 0 degrees Celsius of KCl. And if we look, it would be right here. And that's way under the line, so that would be unsaturated. So that's how we use our solubility graphs to tell if something is saturated or unsaturated. And then at what temperature do KCl and NaCl have the same solubility? I'll let you guys answer that one on your screen here. All right, and that's, I think, where we're going to stop off for today. So some quick notes. We've talked about it in class. Now you have it in your notes. And we'll see you in class. Bye for now.